Okay. Good morning, ladies and gentlemen. Let's go through the question. So for the lesson about thing, works and energy. Question number 1. A van of mass 2000 kg is traveling at 10 ms -1. Calculate its kinetic energy if its speed increased to 20 ms -1. That means from 10 to 20 ms -1. By how much does its kinetic energy increase? So for this one, we use the equation to find out the kinetic energy, right? So that means that how much does kinetic increase? So we use E K equal to 1/2 mv minus u squared. So that means it will be equal to 1/2. Mass is equal to 2000 kg. V, that means that 20 minus 10 squared. So at the end, we get that it will be 100,000 joule. Or we can write in 1 times 10 the power 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 joule. Okay. 100,000. 100. Okay. This means should be like that. 100,000. Okay. 1 times 10 to the power 5. Sorry, this one. Okay, sorry. So that means that, okay, we use 1/2. Okay, this one, let me see. So the speed, we cannot do it like that. Okay, so first, what we need to do, we need to find out the u square first. Okay, because this one, the power square, we use 1/mu square. Okay, EK, that means this is initial. Initial, that means 1/2 m 2000 times with u square, that means it will be 10 squared. So we get that it is 1 times 10 the power 5 joule. For EK final equal to 1/2 mv squared. So that means it will be equal to 1/2 m still 2000. V will be equal to 20 squared. So that means that this we will get that it will be 4 times 10 the power 5 joule. So that means increase. What is the the change in the kinetic energy increase? Change of the EK is equal to EK final minus EK initial. So that means it will be 4 times 10 the power 5 minus 1 times 10 the power 5. So how much difference? It will be 3 times 10 the power 5 joule difference. Okay, so this is for the question number 1. Question number 2. A crane lifts a crate upwards through a height of 20 meters. That means it must be equal to mgh. The lifting force provided by the crane is 5 kilonewton. The F provided is 5 kilonewton. How much work is done by the force? And how much energy is transferred to the crane? So first, to find out the work done, we use that W equal to Fs. Once we use W equal to Fs, that means F, how much is the F? Okay, that means 5 times 10 the power 3 times with the S of 20 meter. So how much is the work done? So here we get that it will be 5 the power 20 the power times 10 the power 3 times with 20 meter. So we get that this will be equal to 1, 2, 3, 4, 5. 1 times 10 the power 5 joule. Okay. After that, how much energy is transferred, okay, to the clamp? So if there is no energy loss, okay, if no energy loss, so how much of the energy transfer? So energy is, okay, 1 times 10 to the power 5 joule. Okay, if there's no energy loss, if any energy loss, different story. Okay, get it? Now we move to question number 3. So I need to clear the screen, yeah? Countdown, 5, 4, 3, 2, 1. Let's go to the question number 3. A block wedging at Newton's slide on horizontal frictionless table with a speed of 4 ms-1 is brought to rest, that means 0 ms-1, in compressing a spring in its path. By how much is the spring compressed if its force constant is 0.25 kilonewton per meter? First, a block slide on a horizontal frictional table with a speed of 4 ms-1. Okay, that means that here, let's say we have a spring like that. So a block is moving with a speed of 4 ms-1. Okay, wedge at Newton. So compress, hit the spring and compress the spring until stop. The spring with K equal to 0.25 times 10 to the power 3 Newton per meter. Okay, so first, kinetic energy of the block will convert to the potential energy. The loss of the kinetic energy, because at the end it will stop, right? Loss of the kinetic energy will be equal to the gain of the elastic potential energy of the spring. So what we want to find, by how much is the spring compressed if the force constant? So that means we want to find how much of the X. So here we use E, K, kinetic energy equal to potential energy of the spring. 1/2 mv squared will be equal to the energy 1/2 fx or kx squared. But given that is the spring constant, right? So we use kx squared. Find out how much is the x. So 1/2 cancel each other. That means that m at Newton, right? Okay, so at Newton, that means that convert to mass. W equal to mg, right? That means that at Newton equal to m times 9.81. So m equal to how much? M equal to at over 9.81. We get that 0.815 kg. 0.815 kg times with the speed 4 square 4 ms negative 1 equal to k 0.25 times 10 to the power 3 kilo. Then x squared. So how much is the x? So I get that it will be equal to 0.22 at meter. Okay. Question number 4. A block of mass equal to 1 kg moving on a horizontal surface with an initial speed equal to 2 ms negative 1 enter a rough path. Okay, rough path, this means that with a friction ranging from x equal to the distance 1 equal to 2.01 meter. The retarding force, that means that the force caused the object to decelerate on the block in the range is F equal to negative kx, where k equal to 0.5 joule. Okay. What is the final kinetic energy and speed Vf of the block as is across this path? So this means that now the force will reduce. Okay. Yes, Jasper. Any question?
Teacher, Alex at waiting room.
Eric is at the waiting room. Okay, Eric and Khalid. Okay, hari ini ada seorang tak datang. Siapa tak datang? Ada siapa pergi vaksin ke? Tak ada ya? Okay, tak apa. Nanti baru saya. Okay, check. Okay, so a block of mass. Okay, now a block of mass. So that means that from here we notice that. Okay, it should be like that. Let's say from a concept of graph. Okay, so it is from the range of 0.1 to 2.01. So in this path, okay, before that, it may be moved with a constant force. Constant force. When it's past enter the rough region, that means that the force will reduce. Is it reduced constantly or not? We don't know. Okay, maybe it's reduced with a curve or not curve, never mind. But after that, up, okay, when it's up of the, what is that? Out of the region, okay, it's not important. So now what we need to do is, given that F is equal to negative kx. Sorry, this part, negative kx. Negative kx means that is the, what is that? The gradient is negative. Okay, so that means that, let's say the f, what is the function of the f? So from here, for this part, f is equal to negative k over x. So what is the final kinetic energy? This is x, right? Okay, so from here, what we can find, actually, we wish to find the area under the graph. Okay, so from here, the change in the kinetic energy. Okay, kinetic energy, final kinetic energy minus the initial kinetic energy. will be equal to area under the graph. That means we find the integration from 0.1 to 2.01. Okay, for the formula negative k over x dx. Okay, so what we can do is 1 over x, integration of 1 over x. Okay, final minus initial, how much? Kinetic energy initial 1 over 2 mv initial square equal to this will be okay, final. Okay, so from here, let me see. It's in negative form. Final minus initial. From 2.01. Okay, that means that find out this one negative k 1 over x. That means is it possible I write it like that? Okay, okay, you look at here, yeah. So I do it. That means that negative k, I take out the k, integration of 0.1 until 2.01. Okay, times with 1 over x dx. Okay, so k f minus initial, so this means that 1 over 2 m. What is the mass of 1 kg? V initial speed is 2 ms negative 1 square equal to negative k. Okay, negative k is equal to 0.5. Integration of 1 over x dx. Okay, integration of 1 over x dx, it will be equal to ln. Okay, it will be equal to ln 1 over x, 1 over x dx, it will be equal to ln 2.01 over 0.1. Okay, so this is the for the integration of 1 over dx. At the end, no need to draw graph, but the graph is help us to understand why we need to do the integration. Okay, integration because we want to find the area under the graph. Okay, so no need to draw the graph, but important is the step and the answer. Okay, so that means that after that, okay, I need some more space, so I erase this part. Okay, so from here, kf 1 over 2 mv square, we will get that it will be Kf minus 2 equal to 0, negative 0.5. That means that what we from the calculation, we get that negative 1.5. So at the end, final kinetic energy equal to 2 minus 1.5. So this means it will be kinetic energy, okay, is equal to how much? 0.5 joule. So what is the speed? Kf equal to 1 over 2 mv squared. So 0.5 is equal to 1 over 2 times with v. M mass is equal to 1 kg v squared. So how much of v final? Zero 0.5 times 2 is 1. 1 divided by 1. So at the end, 1 ms negative 1. Okay, get it? Now, I need to move to next question, yeah? Countdown, 5, 4, 3, 2, 1. Clear. Question number 5. Okay, so a neutron, one of the constituents of a nucleus is found to pass 2.6 meters apart in a time interval of 1.8 times 10⁻⁴ seconds. Assuming its speed was constant, that means constant speed. Find the kinetic energy. How much of the kinetic energy if the mass is 1.7 times 10⁻⁻27? So from here, we use the concept V is equal to D over T. Okay, the distance. So that means equal to 6 meters over the 1.8 times 10⁻⁴. So we get that it will be equal to how much? It will be 3.3 times 10⁻⁴ ms negative 1. And by kinetic energy, Ek equal to 1 over 2 mv squared. Okay, 1 over 2 mv squared, that means equal to 1 over 2. What is the mass? Mass is equal to 1.7 times 10⁻27, negative 27 kg. Speed 3.3 times 10⁻⁴ ms negative 1 squared. So we get that the kinetic energy will be equal to 9.3 times 10⁻⁻19 joule. That's all. Okay, for neutron, if they didn't ask us to convert to the unit of EV, so no need to convert. Just left the answer in joule. Except they ask us if need to convert to EV, this means that use the 9.3 times 10⁻⁻19 joule divide by 1.6 times 10⁻⁻19. So we get the answer in EV. Okay, that one for the what's that for the for either it is radioactive or it is the kinetic energy of the radiation. But no need to convert if the question didn't ask us to convert to EV. Get it? Okay. Ladies and gentlemen, now we move to the next worksheet. Let's take up the lesson number 19, conservation of energy. Okay, question number 1. Use the work energy theorem to derive an expression. Derive an expression for what? The gain in potential energy of a body of mass m when it's lived through a height h. That means the mgh. So another one, the gain in a kinetic energy when a stationary body of mass m is acted by a force and its velocity increased to v. Let's move to the what's first question 1. So that means the work done will be equal to the gain in the potential energy. Okay, salin dulu sebab cikgu tersilap guna pen. Okay, so saya terpaksa clear baru saya boleh gerak. Don't know can select or not. Oke, sudah? Okay, so I clear the screen, yeah? Countdown, 5, 4, 3, 2, 1. Okay, next, we go through the question B. What will be the question B? What will be the answer for B? Okay, this Zoom less than 1 minute will, okay, we'll stop, yeah? So this means that we will continue back after the Zoom stop. Okay, so from here, kinetic energy is equal to Fs. So by substitute the A into the formula MAS, so we get that the final we get it is 1/2 mv squared. Okay.